Welcome back to MOVITRAC LTE-B Plus Basic and Intermediate Training. This is session 5. In our last session, we learned how to access the parameter tree using LT shell. That actually gives us a lot of extra power because it makes it much easier to play with your MOVITRAC, to change parameters, and to see how they affect the system. We're going to continue exploring parameters by taking a look at a particular way of controlling a MOVITRAC LTE-B+, something called terminal control mode. This is actually a very powerful concept. VFDs are often operated in this mode. It gives you a lot of flexibility. You can do a lot of interesting things with it. So let's take a look. First of all, a few big ideas. What is terminal control mode? Well, it's an operating mode in which digital signals, in other words, on-off signals, control the VFD. In many cases, we use switches to supply the digital signals, but there are other ways. Some people call terminal control mode binary mode because it uses on-off signals, and that is certainly okay, but I should mention with the MOVITRAC LTE-B+, analog signals, in other words, variable voltages, may also be involved, and of course these are not binary signals. So, terminal control mode on a MOVITRAC LTE-B+ is actually a mixture of binary and analog signals. We'll see how this works in just a few minutes. If you wish to set up your MOVITRAC LTE-B+ to operate in terminal control mode, you're going to make connections to the front I/O connector. This is right out on the front on the IP20 model. Of course, it's inside under the protective cover in the IP66 model, but the signals are identical. What are some things that you might attach to this connector to operate the VFD in terminal control mode? Well, it's very common to connect up switches. These supply digital control signals. You might also connect up an indicator or two, such as lights. These simply provide status information. And in some terminal control modes, you might wish to use a potentiometer. A potentiometer is a knob-controlled device that has a variable resistance. If you wire it up in the correct way, it will provide a variable voltage signal, which can be used to control, for example, the drive's speed. So these are devices that you might typically wire up, but there's another possibility as well. If you have a PLC with digital I/O capabilities or relay contacts, it can control a MOVITRAC LTE-B+ in terminal control mode as well. It would function, for example, just like switches if you're using digital outputs or relay contacts. And you could use the digital inputs on the PLC to read status information back from the VFD. So there are lots of ways to implement terminal control mode. In this section, we'll be doing some hands-on activity using some switches and a potentiometer. We'll get to that more in just a few minutes. Let's talk about how we get connected. This is the MOVITRAC LTE-B+ I/O connector. Incidentally, the LTE-B has the same connector on it, and the signals are identical as well. Let's go over these briefly just so you understand what they're for. First of all, you'll probably notice there are two power supplies available on this connector. There is a 24-volt supply and a 10-volt supply. There are also two ground connections here, both labeled 0 volts. These provide the reference for the power supplies. Now, a little note here, this is very important. These are not heavy-duty power supplies. They're only intended to supply switches and potentiometers used for control. You shouldn't power any external devices other than switches and potentiometers. The reason? There's just not enough current available. Let me give you the ratings here. The 24-volt supply can deliver a maximum of 100 milliamps, and the 10-volt supply a maximum of just 10. So these are definitely not heavy-duty supplies. They're purely used for signaling. A second note here, if you're going to use some kind of external signal source, for example, digital outputs from a PLC, you'll need to connect that source as ground to one of the 0-volt terminals so everything's at the same ground reference. And if you're going to use some kind of external power supply that needs to be referenced, connect it up to the ground connection. Either of the 0-volt terminals will do. All right, let's talk about the actual signals now. Our first two signals are called DI1 and DI2. These are digital inputs, so they look for on-off signals. Then there are two inputs that are actually hybrid signals. DI3 and AI2 and AI1 and DI4 can be either an analog input or a digital input. They can't be both at the same time. You configure it by setting parameters in the drive. So depending what you're doing, they can either be on-off signals or they can accept analog signals, voltages, or currents. We'll talk about those more as we go along. There's also a hybrid output signal. It's called AODO. It can be either an analog output or a digital output. Again, it can't be both. It's just one or the other, but that can be useful for providing status information. And then finally, there is a programmable relay contact. The relay contact is a kind of digital output. If you wire it up to a power supply, you can use it for signaling. You can also use it to control a small device. It does have very limited current capability, so you can't do anything too hefty with it. Let me mention right here, the digital inputs follow what's called 24-volt logic. That means they consider something close to ground a low and something near 24 volts a high. The maximum voltage you should apply to one of these is 30 volts, and you can also see the logic window. Between 0 and 2 volts is treated as a low, and between 8 and 30 volts is a high. Anything between 2 volts and 8 volts is considered undefined, and you should stay out of that range. The analog inputs can accept a variable voltage between 0 and 10 volts, or a current between 0 and 20 milliamps or 4 and 20 milliamps. These are all common standards for various industrial devices. The digital analog output, when it's operating in digital mode, will also follow 24-volt logic conventions, but if you configure it as an analog output, it will provide a 0 to 10-volt voltage output. Regardless of which mode it's in, you should never draw more than 10 milliamps from this particular output. And then finally, the relay contact has an AC voltage max of 250 volts, a DC voltage max of only 30 volts, and a current rating of 5 amps maximum. So these are the parameters that you need to operate within electrically in order to be safe. Now this is how you should wire up your connector to do the activities in this class, and this is how my demo unit is wired up. Digital inputs 1, 2, and 3 are connected to single-pole, single-throw switches, which are connected up to the built-in 24-volt supply, so these inputs are treated as purely digital. Analog input 1 is connected up to the wiper of a potentiometer, which is energized by the 10-volt built-in power supply. This will be used mostly for speed control, but we will use it for one other thing as well. So you should connect your demo unit up in a similar way. Let me give you a handy tip. If you need to connect higher voltage signals to the digital inputs, let me remind you there is a device called the 110-volt or 230-volt converter card. You can use this as an interface between these higher voltage signals and the low voltage digital inputs. So if you add this, it scales the voltages appropriately and allows you to safely control the VFD using higher voltage digital signals. So file that away in your toolbox. It might be handy. Let's talk about terminal control mode now in a little more detail, how you set it up. Parameter 12 in the basic parameters selects the VFD control mode. Now we have used this parameter before to select keypad control. Remember, for our previous activities, we put a 2 in this parameter so that we had bidirectional keypad control. For terminal control mode, what you'll need to do is get into this parameter and change it to a 0. That selects terminal control mode. Now, there actually isn't just one terminal control mode. There are actually quite a few of them. So instead of calling them different modes, we say these are variants on the control mode. Let me define that term so you understand what I'm talking about. Terminal control variants are digital and analog input assignments that control the VFD in different ways. There are actually 14 different ways you can use digital and analog signals to control a MOVITRAC LTE-B+. The MOVITRAC LTE-B only has 13 variants, so there's one less. All right, let's talk about the variants here. How do you select which variant you want? Well, you have to go into the extended parameters. You go to parameter 15 in the extended parameters to select the variant. So you'll put a number in here. By default, it is 0. But here's the list of all the variants. You notice we have 14 here. This is the MOVITRAC LTE-B+. The MOVITRAC LTE-B has all of these except for the very last one, mode 13. That is a feature that was added when they updated the LTE-B to the LTE-B+. We'll talk about that in another session. Now you can see that each one of these has a number, that's the variant number, and then they have 4 signals. What they're doing is they're showing you how the 4 inputs are configured, what mode they operate in. Now perhaps you're feeling a little confused as you look at this, all these combinations, you're wondering what's the difference between these, what do all these signal names mean? We're going to talk about all the different signals and what they do, and then we'll look at some examples so you can get an idea how the VFD is controlled in several of the different variants. We're not going to look at all 14, that would take far too long. We'll look at about 5, and that will give you a good understanding of how to interpret the others. In most variants, the digital signal states, whether they're on or off, will control various drive functions. I'll mention as well that for most variants, not all but most, analog input 1, digital input 4 is treated as an analog input and is meant to be connected up to a speed control potentiometer. This is called analog 1 reference. If you see that as a signal name, it means a potentiometer feeding a voltage that ranges between 0 and 10 volts and is meant to control the drive's speed. So that's going to be true for most variants, although not all of them. All right, let's look at the digital signals and I'll explain what each of them can do. The first is called stop run. With this signal, if the digital signal is off, the motor will stop, and if it's on, the motor will run. That's pretty obvious. Then there is a version very similar to this called fast stop and run. It does exactly the same thing, but the difference is when the signal is off or low, it does a fast stop of the motor using the ramp in parameter 24. When it's on, it runs the motor. Another signal is called stop forward run. When it's off, the motor stops, and when it's on, the motor runs in the clockwise direction. So this is kind of a combination of start, stop, and direction control. There is a counterpart to this called stop reverse run. Does pretty much the same thing, except it runs the motor counterclockwise when it's on. Alternatively, you can use a digital signal just to pick direction, forward, reverse, that selects clockwise or counterclockwise rotation, depending upon whether it's off or on. There's something called trip and run. This is used for triggering faults, for monitoring external fault sensors. If it's off, then a fault has occurred. If it's on, no fault has occurred and the drive can run normally. We won't be looking at this in this session. We'll be looking at this in the next session. Analog 1 preset 1 selects between either a speed control potentiometer if it's off or a fixed preset speed if it's on. Analog 1 preset 1 2 selects between a potentiometer speed control and one of 2 preset speeds. Preset 1, preset 2 is used in combination with this previous signal to select between 2 different presets, preset 1 and preset 2. And then there's another version of this where you can select between 4 preset speeds and a maximum speed. If the signal is off, you get presets 1 through 4, and if it's on, it goes to the maximum speed. That's the top speed that you say the drive can run. It's in parameter 0, 1. And then finally, there's what's called the fire and normal mode. This is something only the MOVITRAC LTE-B Plus supports, something called fire mode. We'll talk about that in another session. If it's off, you're in fire mode. If it's on, you're in just normal operation mode. And then finally, for some variants, digital inputs can form a 2-digit binary number that selects between 4 different speed set points. And you can see the combinations here. If you have 2 signals doing this and they're both off, it picks the first preset. If the first is on and the second's off, you get the second preset. If the first one is off and the second one is on, you get the third preset. And if they're both on, you get the fourth. We'll be looking at that in just a few minutes. Okay, now if you've still found that a bit confusing, don't worry, just hang on for another couple minutes and I'll show you some examples, and I think all this will crystallize into clarity. But I do want to point out where we set up these preset speeds, since so many of the variants pick a preset fixed set point. The preset speeds all live in the extended parameters. They are parameters 20 through 23, and these are 4 fixed speed set points that you can set up to whatever speeds you like. And here they are. So simply go to these 4 parameters and put in the speeds that you like. The VFD will supply some default values, but you can easily change these. Let me give you an important note, though, before we go too much further into this. You need to be sure that the stop mode, which is in parameter 5, is set to either 0 or 2. That is the ramp to stop mode. We talked about that in a previous session. You must set it to one of these two values. If you set it to coast to stop, you will not get controlled stops when you're in terminal control mode. You'll get coast stops, in other words, uncontrolled stops. So if you want to have the predictable ramp stops, be sure to set parameter 5 to 0 or 2. Okay, let's take a look at some variant examples, and we'll try to make all those signal names make sense. We'll take a look at the default variant that you will get if you just activate terminal control mode and don't make any other changes, and that is variant 0. Let me show you how to interpret a variant. First of all, the number at the very beginning is the variant number. Then we have 4 inputs on our I/O connector, DI1, DI2, DI3, and AI2, AI1, and DI4. And underneath it will be a description of the signal associated with it. So in this particular variant, variant 0, digital input 1 is assigned to stop run. That means that if you put a 0 on this input, in other words, you connect a switch to it and turn it off, it will stop the VFD, and if you turn it on or bring it high, it will run. DI2 is a direction control. It's assigned to forward reverse, so if you send a 0 into it, you will get clockwise rotation, and if you put a 1 in there, you'll get counterclockwise. Digital input 3, analog input 2 is connected up to a digital signal, and it's connected to analog 1 preset 1, and what that means is if you put a 0 in, it will use the speed control potentiometer to control the speed of the VFD. But if you change this input to a 1, it will go to a preset. It will go to preset number 1, which lives in parameter 20, and run the drive at a fixed speed. And then analog input 1, digital input 4 is wired, in this case, to a potentiometer. It is the 1 analog signal here. The other 3 are digital. So let me give you a few examples of different possibilities here. Let's say our first switch is off, and it doesn't matter what the other 2 are. That's why there are dashes there. This is going to bring the VFD to a stop. It will do a normal stop. It will ramp to a stop using the standard deceleration ramp. If you turn the first digital input on and the other 2 digital inputs off, you will run clockwise with potentiometer speed control. So you'll be able to turn that knob and you'll get a full range of speeds between 0 and the maximum. And you'll do this in the clockwise direction. If you turn all the switches on, that will run the drive. It will pick counterclockwise rotation, and it will switch to preset speed number 1, which means the VFD will go to parameter 20 and pull the fixed speed out and run at whatever that speed is. So this gives you both fine control and a fixed control. You have direction control, and you have run and stop. So this is one variant. This is variant 0. Let's look at another variant and see how this works. In this variant, variant number 1, DI1 is assigned to run stop, DI2 is to analog 1, preset 1 and 2, DI3 AI2 is assigned to preset 1 or preset 2, and analog input 1, DI4 is again an analog reference. So the first one controls run and stop. If it's a 0, it will stop. If it's 1, it will run. Digital input 2 selects between the potentiometer and 2 preset speeds. So if you have the switch off, the potentiometer will control the drive. If you have a 1 in there, you will be able to have one of 2 speeds, and that is what the third input does. It selects between those 2 speeds. If it's 0, you'll get the first speed. If it's 1, you'll get the second one. And then, of course, again, that fourth input is connected up to the speed control potentiometer. So if the first switch is off, the VFD stops. It doesn't matter what the others are set to. You'll get a normal stop. If you turn the first switch on, the second switch off, you'll be in potentiometer control mode. It doesn't matter what the third switch is in. You'll be able to get fine speed control between 0 and maximum. If you turn the second switch on and the third switch off, you'll run at preset speed number 1, which comes from parameter 20. And if you turn that third switch on, you'll get the second preset from parameter 21. So this gives you fine control in 2 different speeds, but notice you don't have direction control. Now you may be wondering, if you don't have a signal that controls rotation, how do you get clockwise and counterclockwise rotation? The answer is when you're operating in preset mode, the sign of the preset determines the direction of rotation. Positive will cause the drive to rotate clockwise, while a negative preset will give you counterclockwise rotation. Potentiometer control mode is fixed at clockwise. Let's look at another example. This is variant number 2. Notice this one has a stop-run control assigned to DI1, so that works in the usual way. But DI2 and 3 are a little bit different. These two signals form a 2-bit binary number that selects between one of 4 preset speeds. And then finally, analog input 1, digital input 4 is now being used digitally. This is not an analog signal in this case. It selects between either the 4 presets that you select with DI2 and DI3, or it will just run the drive at the maximum speed programmed into parameters 0, 1. So for example, if digital input 1 is off, the VFD will stop normally. If digital input 1 is on, digital inputs 2 and 3 are both off, and digital input 4 is off, you'll run at preset speed number 1. So those two middle switches select preset number 1, and then the 4th input, which is off, selects those 4 presets. If you turn the first digital input on, the second one off, the third on, and the 4th off, you'll run at preset speed number 3 because you have an off-on pattern that selects preset speed 3. And again, we're using the preset speeds, but if we just want to run at the maximum speed, doesn't matter what the two middle switches are turned to. If the two outer ones are both on, you'll run at maximum speed. That's the P01 speed. This mode is nice because essentially you get 5 preset speeds, the motor maximum, and then the 4 that you can set up yourself. Variant 5 uses a somewhat different approach to controlling the drive and its direction. It uses a pair of inputs, both to start and stop the drive and to select direction. Digital input 1 and digital input 2 work together. If they are both off, the drive will be stopped. If one of them is on and the other is off, the drive will run either clockwise or counterclockwise. And if they are both on, the drive will do something special. It will do a fast stop. Digital input 3 selects between either a potentiometer speed control or a fixed preset, preset number 1. Analog input 1, digital input 4 is the potentiometer. Let's see how some of these combinations play out. If the first two digital inputs are off, the VFD will do a normal stop using the standard parameter 04 ramp. If digital input 1 is on and digital input 2 is off, then the drive will run clockwise, and if the third input is on, it will pick the preset speed in parameter 20. If you turn digital input 1 off, digital input 2 on, and digital input 3 off, you'll get counterclockwise rotation with potentiometer control. And if you turn both digital inputs 1 and 2 on together, you will get a fast stop using the ramp in parameter 24. So that's a little bit different. Again, just another way to control the VFD. One more, and that's the last one we're going to look at. We're looking at variant 12. Variant 12 is similar to a number of other variants that you've already seen, but there's one important difference. The stop-run signal works exactly the same, but there is a second stop-run signal assigned to digital input 2. It's called f-stop-run. These two signals allow you to select between running and 2 different stop speeds. If you stop the VFD with digital input 1 by turning it off, you'll get a normal stop, and if you stop it using digital input 2, you'll get a rapid stop. Digital input 3 selects between the potentiometer and a preset speed. Analog input 1, digital input 4, again, is the potentiometer. So, if digital input 1 is off and digital input 2 is on, you will get a normal stop using parameter 04. If you have digital input 1 on and digital input 2 off, you'll get a fast stop using parameter 24. If they are both on and digital input 3 is off, you'll get potentiometer control. And if they're all 3 of them on, you will run at preset speed number 1, which comes from parameter 20. So again, just another variant that allows you to control the VFD in what could potentially be very useful for your application. All these combinations are rather interesting and useful, but there are a lot of them, and keeping them straight can be a bit of a challenge. So I think it's time to stop talking and do a hands-on. Here are the instructions. I'd like you to try this on your VFD. Change to terminal control mode and select variant 9. We haven't looked at that one, so you'll have to figure out how it works using what you've learned. I'd like you to set the 4 preset speeds to 100, 250, 500, and 1000 RPM. I'd like you to set the normal deceleration ramp time to 4 seconds. Then work out the digital input switch settings to run the drive in each direction at each preset speed. And finally, test your drive to confirm operation at all speeds in both directions. And I'm going to give you a hint here that probably won't make much sense right now, but as you dig into this, it will. Remember, your demo unit has a potentiometer connected to its 4th input. Normally, this is used to provide analog speed control, but you can use it as a digital on-off switch simply by turning it all the way counterclockwise for off and all the way clockwise for on. So that's a hint. I think you'll see that that could be useful in just a few minutes. So, pause the video and do the hands-on. All right, well, I hope you succeeded and were able to control your drive. I'm going to demonstrate how to do it now, so if you had problems, hopefully this will clear things up. And if you don't have a demo unit, you'll be able to see how you would have done this if you did have one. All right, let me explain first of all how variant 9 works. Digital input 1 and digital input 2 control both whether the drive can run or not and what direction it runs in. Digital input 3 and analog input 1, digital input 4 select one of 4 fixed set points, so they together form a 2-bit binary number. Incidentally, this is why I told you how you can use the potentiometer as a switch, because you're using it, in this case, as a bit for selecting one of your presets. All right, I've created 2 tables here, one for the clockwise direction of rotation, one for the counterclockwise direction. Basically, the only difference between these 2 tables is whether DI1 or DI2 is on. When DI1 is on, you get clockwise rotation. When DI2 is on, you get counterclockwise rotation. When they're both off, the drive stops, and if they're both on, incidentally, you get a rapid stop. DI3 and DI4 form the 2-bit binary number that picks between the 4 presets. You can use these tables to test your drive out. So let's go into LT Shell. I'll configure my drive, get it ready to run, and then we'll test all these combinations out. All right, as you can see, I've got LT Shell started and I've scanned into my drive, so I'm ready to go ahead and get it configured. It's all set the way it was in our last session, so nothing's changed since you last saw it. The very first thing I'm going to do before I forget is I'm going to go into real-time edit mode by clicking the real-time edit mode button. It's very easy to forget this, change some parameters, and then not realize that they haven't actually changed in the VFD. That can be very mystifying why your changes don't seem to be taking effect. So go into real-time mode and you won't make that mistake. All right, so here's what we have to do. According to our instructions, the first thing we need to do is change to terminal control mode. So I'm going to go to parameter 12 and change it from 2 keypad mode bipolar to 0 terminal mode. I need to select variant 9. Now that is in the extended parameters, so I will go up here to the extended parameter tab. And we're after parameter 15, digital inputs function select. I'm going to set this to variant 9. Now we need to set our presets, and those are parameters 20 through 23. You can see they have some default values, but I'm going to change these. Change the first to 100, the second to 250, the third to 500, and the fourth to 1000. So those are my presets. Now I need to change my deceleration ramp to 4 seconds, so I'm going to go back to the basic tab. You can see it's set to 10 from our last activity. I'll change it to 4. And I'm also going to do one other thing. I'm going to just double check that I have a ramped stop mode. Remember, parameter 5 controls that. It should be set to either 0 or 2. It's currently set to 2, which is fine. That has a ramp to stop. Otherwise, remember, we get uncontrolled stops. All right, so that should be everything required to get our drive ready to go. So I'm now going to take it out of real-time edit mode And I'm going to go over to my drive and start flipping a few switches on it and see if it controls as I expect. All right, I'm ready to run. I'm going to start by turning the switch connected to DI1 on. That should run in the clockwise direction. All right, we're running at 100 RPM. Now let's go to the next speed by turning DI3 on. That'll give me 250. All right, now we're going to turn the pot all the way up to give us that extra bit. And we have 500 RPM, and finally we'll go to 1000 by turning both switches on. Works fine. Bring it to a stop. We'll try counterclockwise, do the same thing, but we'll put our switches both back to 0 first. Counterclockwise, minus 100, minus 250. All right, we're going to turn the pot all the way up again to create a 1 bit. Gives us 500. And finally, we go up to 1000, both bits on. So counterclockwise works. Let's stop it, and let's try one final thing. Let's start it up again and do a rapid stop by turning both on at the same time. And boom, you can see it stops a lot quicker, just like what we expect. All right, well, that is the end of session 5. I hope you found that productive and interesting. As you can see, terminal control mode is a bit of a rabbit hole. It definitely has a lot of combinations and possibilities. In fact, we're not done with terminal control mode. There are more things I want to show you, but I thought this session was getting kind of long. So in session 6, we will do part 2 of terminal control mode, and we'll learn some other things that you can do with switches, potentiometers, and similar control devices. See you then.